All right, the last concept that I want to talk about is symmetry. And there's two types of symmetries that we're going to go through. And those are rotational symmetry and reflective symmetry. All right, rotational symmetry means the following. So a figure will have, or any element can have rotational symmetry as long as it can be rotated about its center and map back onto itself perfectly before it completes a full rotation. Okay, so if we took this little recycle symbol here, right, can we take this symbol and rotate it so that it maps back onto itself before it completes a full rotation? Yeah, so we want to figure out how many times we can do that. So as we take this figure and we rotate, and so as we're rotating it, here it maps onto itself once. We can continue. It maps onto itself a second time. Continue back to the original starting point, maps onto itself a third time. Okay, so this figure is said to have threefold rotational symmetry. Right, so the naming of rotational symmetry is the number of times it can map onto itself as it rotates about its center and back completing a full rotation. All right, so if we take this square flag example, okay, how many times can we rotate this so that it maps back onto itself within one full rotation? So here's once, twice, 3 times, 4 times. Okay, so it's going to have what's called fourfold rotational symmetry. Right, and looking at the next figure, what's that going to have? Again, 5-fold, and then the final one, 6-fold. Okay, do you think it's possible for a figure or element to have 2-fold rotational symmetry? What would be an example? A what? A rectangle? Okay, so let's take a look. If we took a rectangle, okay, that's not a square. So if we took this and we rotated it, it doesn't map yet. There it maps once, and then back to the full rotation, maps the second time. And so this would be considered 2-fold rotational symmetry. How about a rotational symmetry of 1-fold? What do you think? All right, so let's say we took a scalene right triangle. If we were to rotate this figure about itself, would it ever map back onto itself anytime other than at the completion of a full rotation? No. Okay, so this would be said to have no rotational symmetry. There's no such thing as 1-fold or 0-fold. Okay, because anything would have that, right? So they're not going to distinguish it. Okay, so the rotational symmetry begins at 2-fold. Okay, now there's one last shape that will cause some potential confusion on the labeling and naming, and that's this shape. Okay, so if you look at this shape, if we were rotating this, how many times can we rotate this about itself and have it map back onto itself? An infinite number of times, right? So we're not going to specify that it's an infinite fold symmetry. All you'll have to say for this is that a circle has rotational symmetry. And you're not going to have to identify specifically what it is. You'll just have to know, like, does it have symmetry, or is it symmetrical or not? Right. In addition to rotational symmetry, there's also reflective symmetry that you need to be aware of. Reflective symmetry is, again, pretty straightforward. Let me adjust this picture here slightly before we move. All I'm doing is thickening these. I wanted these lines to be more symmetric here. All right, so assuming these red stripes here on the diagonals are... All right, if we're looking at the reflective symmetry, what reflective symmetry means is the figure can be reflected across a line of symmetry and remain unchanged. And now, that doesn't mean that it gets cut into two equal parts. What it means is when it gets cut and folded along that line, or reflected or a mirror image across that line, that it maps back onto the original part perfectly. Okay? So if you took like this rectangle here, and we wanted to see are there any lines of reflective or reflective lines of symmetry on that. And if we were looking to sketch those lines, okay, would this line right down the middle fold over onto itself and map directly onto itself? Yes. What about this horizontal line across the middles here? Again, assuming I drew it right in the middle, it would. But what about a line from corner to corner? Now, does that line cut it into two equal pieces? But do those pieces fold on that line and map together? No, because this bottom piece is going to fold up here. So it would fold and look like this, which is not reflective symmetry. And so when you're looking at something like that, the only lines of reflective symmetry would be the vertical and the horizontal. Okay. So looking at this image right here, would we have any lines of symmetry? Yeah. Vertical, horizontal. Would any of the diagonal lines allow this to be folded and mapped back onto itself? Careful. Remember, this is kind of like a rectangle here, right? It's elongated. So if we drew a line through here, yes, it would cut it into two equal pieces, but when we reflected this piece up here, it would be out here more. It would look more like a butterfly, right? Does this look like it splits it into two mirrored images? No, they're each other. So there's no diagonal lines of symmetry on this. Now, if we go up here, on this one that's not elongated, we do have our vertical and horizontal. And now, does this diagonal line reflect it right back onto itself? Yeah, and we can continue that process all the way around this whole figure. So here we would have all of these lines of symmetry. All right, so assuming the red stripes on this flag and are equal consistency, and assuming that's a perfect square, how many lines of symmetry would you have in this? You have vertical, horizontal, diagonal, and diagonal. Okay. Questions about those? All right, so just really quickly, I want you to see, we're just going to talk through this together here. You don't have to do it specifically. I just want to kind of go over it. All right, when you're looking at this, a rectangle. So is the rectangle going to have any rotational symmetry? It's going to have twofold. So in looking at that, oops. We have twofold rectangle or rotational symmetry, and then the reflective lines of symmetry, just a horizontal and vertical. And what about a square? How many rotational symmetry? Fourfold. And how many reflective lines of symmetry? Again, 1, 2, 3, 4. And what about an equilateral triangle? Threefold rotational symmetry and 1, 2, 3 reflective lines of symmetry. And what about a rhombus? Will it have any rotational symmetry? Think about it. If we rotated this point, it's not going to map here, but will it map back to here? Yeah, so it is going to have twofold. And will there be any reflective lines of symmetry? Diagonal and diagonal. So we'd have those two reflective lines of symmetry. And what about this figure here? Rotational symmetry is twofold, reflective, horizontal, vertical, and then finally this last shape, also twofold, vertical line, horizontal line. All right, the one other figure I do want to add here, just to make sure there's not like a false pattern created, and that is if you have a parallelogram that's not a rhombus or a rectangle, is there going to be any rotational symmetry here? Now think about it. So if we're dealing with a parallelogram here, yeah, this point's still going to map on here and then back, right? So there is going to be twofold. Okay, but is there going to be any case that we can draw a line where these will map back onto each other? No. So there's no, this one's going to have no reflective symmetry. And I just want to make sure that, because the question was asked last class, does reflective symmetry always match the rotational symmetry? And it's not always the case. It just so happens in these symmetric shapes here that that's true, but in a regular parallelogram that's not, or in a parallelogram that is not a rhombus or rectangle, it would not be the case.